so quickly, for those who might not be familiar with this one, and this is totally normal. This is a technique where malware loads an unrelated DLL file and hijacks its memory region instead of allocating its own. So once that's done, it writes its shellcode into the DLL's memory space and executes it. So this is categorized under the MITRE tactic T1055, which falls into the defense evasion category. And now, based on our analysis, Patrick is going to shine more light on it, but the VTI score for this is 2 out of 5. So it's kind of a medium to low priority detection, but still important given how it is often used by loaders like hijack loader, for example, to install payloads of info stealers such as Luma. And it's also seen wine loader, for example, in an APT campaign, APT29, aka Cozy Bear. So with all these, after this summary, actually, I'd like to turn to Patrick. Patrick, I would like to get your take on this around what stands out to you, and are there any patterns, behaviors you think the analyst should watch for? So.
Yeah, so I mean, you already did a great job and you nailed it pretty much. So essentially, DLL hollowing is just another technique of, let's call it process injection, whereas some shellcode is being injected into the current process, right? So we're not currently talking about remote process injection at that point. But as you've mentioned, there is just a process being executed and the process loads an unrelated DLL. Of course, we see specific DLLs being used quite often or quite frequently, but it can in theory be any DLL that's being loaded into the current process space. Then there's shellcode being written into this DLL, and then the execution is just transferred over to that DLL, to that module in the current process. So you may actually wondering why we're going to have this with quite a low score, which is a 2 out of 5, which in theory just flags this as suspicious. And that is due to a specific process that we're going to use here. So whenever it comes to adding new detections that are being able or that are supposed to detect the sample as malicious, that's of course also a bit dangerous, right? You never really know when you release an update. It can in theory cause false positives as well. So we usually follow here a 2-step approach or a 2-step process where once we have finalized and finished the VTI and the implementation side, we essentially release the very first stage of that with a lower score. In this case, as you can see, it's a 2 out of 5 score. Then we just let this run for 1 or 2 weeks and just ensure that we don't observe any false positives and just really correct and intended trigger conditions. And once this has been confirmed, then we are basically going to increase this to a higher score. So in theory, you will likely see in a couple of weeks, 1 week, 2 weeks, maybe an increased verdict of that VTI that's also supposed to directly raise this to a malicious score, because in theory, we're just talking about process injection in a different way. And yeah, that's just to be transparent here. That's a way on how we can ensure we provide the best and accurate detection mechanisms to our customers, while still also ensuring we are not causing any false positives and can ensure everything is working as expected here.